Hello friends, welcome you all once again in lecture series Manufacturing Technology. Today is the 14th lecture. I am Amit Tiwari, Assistant Professor, Department of Mechanical Engineering, Suresh, Gyan, University, Jaipur. The topic of the today is soldering and brazing. So let's start. The objective of the lecture are to develop an individual practical skills to envelop them to reach the level required by the chosen standard, ensuring a full understanding of the brazing and silver soldering process using oxyethylene equipment and all the associated safety requirements. So today we are discussing about some procedure of metal joining by the brazing and the soldering by using the oxyethylene equipment and the associated safety requirement for the metal joining process. At the end of this lecture, the students we will understand that the introduction to AVIL welding processes, second welding, soldering, and brazing comparatively study. The difference between the soldering and the brazing we compare. After that, you will be ensured that what is the better option when you are doing your metal joining. So you will select as per your requirement. Third, that is different method of soldering and brazing and the machine tool. And the last fourth is defects and application of soldering and brazing also discussed in the today lecture. So at the introduction, first portion we are covering as the soldering, and after that we are covering as a brazing. So first the we get that in the soldering and brazing provide a permanent joint to bond metal pieces. So as you see in the picture, that is soldering and brazing are the permanent joint. When you are joining the metal pieces, the two different or dissimilar, or we can say similar pieces, if you want to join as a permanent way. So the soldering and brazing are one of the best option to provide it with good quality of welding material. Soldering and brazing process lies somewhere in between the fusion welding and the solid state welding generally. So as you see in the figure that from the oxyethylene gas I have provided for melting the electrode if I'm the brazing from here, and which portion we will weld and to join the metal, you can test that portion, and by the help of this gas oxygen ethylene, thus electrode are melting and join the metal where they want to join. So it is a very common and now very popular, because if you join the very small particles or if you join very large number of particles, the both are possible in the soldering and brazing section. So it is a permanent way, and this is a new technique are adopted nowadays. Generally, most of the market you can see here, if you are working on computer applications and you are joining some circuit or any small amount of some circuit you will fabricate and at joint some individual part or the small section, then it will happen on the soldering brazing. You do not need to require that is for electric arc welding, thermal welding, plasma arc welding, because these all are the welding are used with a high applications or heavy structure they will use. But in the case of you will join the smallest particles or you join the small area, then the brazing and soldering will help to you. So that's why it is a very common and very most now rapidly they are very adopted process for joining the metal. It is similar or a similar form. Next is what solder, that is soldering defined as the joining of metal using a filler material. Just read the line and just listen carefully. The joining of metal using a filler material. So you just require one filler material for joining the metal of a lower melting point than that of the parent metal to be joined. Obviously, what parent metal you want to join from that lower melting point you require, because if the filler material is melt, then you will fill the gap. Otherwise, how you will fill the gap of the welded joint. So suppose, for example, in this diagram you can see here, these are the joint, these are the two joint, and you want to join together in the single line. So what you do? You would do just test the solder on the place and provide the solder bend by the oxygen gas you pass on the solder, and solder are melt, and during melting the this solder are completely fill up on the empty gap, and after the weld are solidify, it will be permanent joint. So it is the simplest method to joining, and there is no complication we require. What area you want to join, just to touch the solder here and to just pass the arc from the oxygen, and during this arc the metal solder you can the filler metal are melt, and from the molten part of the metal solder material filler material are fill up on the gap, and this gap are when they convert into solidify, it can make it a permanent joint as a weld. So this is the most common type of we can say that process are generally on the soldering. Just we keep the one filler material, and with the help of the oxyacetylene, yes. Soldering as that when we can say that first point are heat both items by applying the soldering iron to the copper plate and the component lid. The first option you can see in this diagram, that is heat. You can, if you want to join a circuit, by this, you can see this diagram. These are the some section. We are just studying the first section of joining the metal by the two wire with the help of the soldier. The first are these are the two defected part. There are the gap between this. You can see this is the gap between the two metal we join. First step, it is a heat both item by applying the soldering iron to the copper plate and the component lid. Heating both the item we want to join, and also the from the solder. To maintain the heat or to maintain the good quality of product. So this by this you reduce the amount of wastage of solder. It's reducing the amount of and we can save the material also. Second point you can see here, these are the starting point to joining this of the two metal. You can see this diagram by filling the material here. So continue heating and apply a few millimeters of solder. Remove the iron and allow the solder joint to cool naturally. So you must keep in mind that the first process is, first of all you heat the which metal you want to join, and also the solder, because during the heat it also make a strong bond. Second point is to join the starting portion to, you can see here these are the two metal are just fill up by the solder, and the third process you can see completely joined by this, you can see in this diagram, third section. It takes only a second or to make the perfect joint, which should appear shiny. So these are the simplest method to join this. It is now very popular in the desk because it have not required any extra skills for to join the dissimilar metals. A good soldering joint that you can see here is smooth, very quiet, shiny, cleaning, and concave fillet. After this, all the conditions are fulfilled, we can say it as a completely good soldering are obtained. Good solder joint are obtained. So as you see in the figure, that is, these are the joint you melt. You can see here these are the filler material to fill the gap between this rod to the surface to join together by the filler material. These are the filler material. This you can see this is a very shiny, smoothly and cleanly and concave. You can these are the concave fillet are obtained. So these indicate that is a good sign of solder joint or we required a such type of joint for the joining time. It indicates the good machinability. It indicates a proper welding procedure we follow. This is also best example if you are doing a soldering, and this all the forms are obtained in a simply way, or we can say that the completely you will be follow this procedure, or it will show this all the 4 points on your welding. It says the good solder joint. Bad solder connection, if you are doing a soldering, and how you can identify this is a good solder and this is a bad solder. So just keep in mind these are the 4 points I've already discussed here. These are the 4 signs to show that a good solder joints. So in this diagram you can show here the cold solder joint and not solder joint. Cold solder joint, that means if this is a rod, you want to make a permanent joint with the surface, and you just fill up the filler material on the between the two gap interval between them, and just wait for the colding. This is the cold solder joint are obtained. So we can say that this is a good soldering. We can suggest one time. But in the second case, you can see a not soldered. That is, the material will remove after the welded easily, because they don't attach the too much making strong bonding between the surface and the metal we join. So it is a part of, we can say it's a wastage of solder material, filler material, of time and the power consumption. So during the machining, you just to be keep in mind that when you are doing a soldering, you just make a perfect joint. And the perfect joint will obtain by completely filling the filler material to the required gap. When the gap is completely filled, or make a completely solidified body or the section where we welded, after solidify, you just check by hand it easily remove or not. If they not remove it, it can make it harder. During the sketching time, you just observe that the soldering will be done perfectly. So it is a symbol to identify the good soldering or the bad soldering. How you can justify this is a good soldering by this diagram? You just, if you shown during the machining process, you saw this type of features. You just imagine that this is a good sign of soldering and this is a bad sign of soldering. With the help of this diagram, you just keep in mind during the machining, but during the metal joining process, it will help to you to identify this is a good weldability or not matching. The soldering tools are such as the first is vise. The numbers are available at the number. Just I'm just telling you. The first is vise. You can see number 1. This is a vise where to fix the workpiece material you want to weld. So with the help of this vices, have we use it to just hold down the workpiece material. Second is safety glasses. Safety glasses used because we during the welding, some oxygen gas are just weld the filler metal, and during the welding, so some unwanted heat are available or occur with the high temperature. So it will directly affect it to your eyes, and it will be harmful to your eyes. So for preventing the eyes, it we required for safety glasses. Third one, you can see solder sucker. These are the solder sucker. Fourth is solder tool. This is fourth is solder tool. Fifth is diagonal cutter. These are diagonal cutter. If you want to cut after soldering, you just use the diagonal cutter. Sixth one is nose peeler. If you want to cut the nose section of the filler material, you cut easily. Why this? Because the sharpness and the very large are very easily to cut the nose peeler. Seventh is soldier. And at this soldier stick, you can see this line. And ninth is damp storage. And the 10th is soldering iron. So you can produce the arc from this on the area you want to join. These are the some tools we required for the soldering. Now solder is an alloy of thin and lead. What is solder? Solder is an alloy of thin and lead, or the mixture of thin and lead are known as a solder. And a solder used for electronics is frequently called a 60/40 solder because it is made of 63% of tin and 37% of lead. So solder are generally used for the electronics item, basically for joining the computer hardware chips, TV, television, and circuit. So such type of electronic items you will be joined with the help of the solder. And it is because it is made up of 63% of the tin and 37% of the lead. 60 to 40 solder melt at the 361 degree Fahrenheit easily with a low temperature. And multi-core solder is usual for from electric work. Multi-core solder is basically used for the electrical work, which is useful for the joining the small particles, a small section on the circuit. It easily be welded. There is no any we can say that the huge amount of temperature generated, as well as to providing a good surface finishing, which we require for the good welding. So these all are the helpful for to understand the complete procedure of the soldering. So soldering is generally, we can say, it is an alloy of tin and lead, the mixture of the tin and lead. And the what percentage? 63% of the tin and 37% of the lead. Now soldering and discussing the typical 25 to 30% we require, and the tip temperature approximation 400 degrees Celsius are obtained during the soldering. So when you are doing the soldering and you just join the circuit and in a particular point where you want to join, you just operate a 25 to 30 volt we required for the power, and that power the 400 degrees Celsius are temperature obtained on the tip of the temperature, like in the this area. When you suddenly join this point, which are having the 400 degrees Celsius temperature, and you join the subtle surface you want to join, it easily be melted. It is a good advantages. We required for that temperature for the specific area to easily join with the help of the solder. Now these are some timing processes that we can cleaning process. First of all, first is apply solder to iron tip. Apply solder to iron tip. This is a working process. We can say a timing process. First of all, this is a solder you can apply on the iron tip. This iron tip is having the 400 degrees Celsius temperature. When you are joining the iron solder to the iron tip, you can find that this section roll tip on damage sponges are generated on the tip section. And this tip section are generally we can say the properly tin solder top tip are generated to easily weld that area we want to weld. So it easily affected by the joining. So when you are doing a machining, before machining, you just clean the surface area, or during the time of a metal joining process with the help of soldering, just keep in mind this all are the process parameters are very easy to understand. You just keep the solder to apply the iron tip, because iron tip have been heated by the 400 degrees Celsius. After that, you second step, you find that the roller tip on the damp sparking are found on the iron tip. And third option is to properly lifting solder on the iron tip on the surface where you want to join. It's easy to join. Easily to join. There's no any complications required for that. So these are some benefits of soldering. If you want to doing a soldering on a circuit or a television, laptop, and we can set some chip you want to weld with the help of, if you are doing some create the, some burn the wire and join on the chip, with the help of the soldering you will be doing. It will easily and very good, we can say that the quality welding will approach. So it is a part of good welding. Now very popular nowadays. Now the soldering iron core maintenance, that is most important. With the help of the maintenance of the iron tip, we are doing a welding. Otherwise, it will not possible. Because how, when, and who will melt the solder? Who will create a temperature at a tip surface of iron? So you can see in this diagram that is a and section on this section. Until what happened, that is a soldering iron may be coated with a thin coat of solder. A soldering iron must be coated with a thin coat of the solder. This will allow for transfer of heat to the workpiece. And this procedure is known as a timing. Because if this tape portion having the huge temperature are having during the soldering operation, this will allow to transfer the heat to the workpiece. With this heat will transfer to joining with the help of this heat, it will easy to weld the material. So it is a responsible point to maintain or to welding the metal will to join with the help of the iron tip temperature to transfer the working of work surface. Yes, now second is that the tip must be kept coated with a shiny layer of solder. The tip must be kept coated with a shiny layer of solder by occasional wiping and applying solder directly to the tip. So the tip must be kept coated with a shiny layer of solder by occasionally whipping and applying the solder directly to the tip. These are the some instruments we use for the basic role play during the soldering. Because if we are not maintaining the temperature of the iron tip, then it is not possible to transfer the heat on the surface of the joint to join, and during this time the stronger not weldability occur. If you want to join a stronger joint, you just keep to maintain the temperature of the iron tip. It is the most requirement. But during the soldering, you just keep in mind that some coat with this shiny layer will be required for the solder of the occasion of whipping and allowing the solder directly to the tip. It will allow you to maintain the surface quality of the workpiece also. It will allow to maintain the quality of solder equipment also. So these all are the fundamentals we required for joining the metal by the help of a solder. Now what is flux? Flux is a chemical compound basically, and it applies and shields the joint surface from air and prevent oxide formation. Although flux will dissolve and absorb oxides. So what is flux? Flux is a chemical compound, and this flux is applied and we just maintain the coating or we can shielding of the iron tip because we're preventing from the oxide formation. Because flux all through will dissolve and absorb the oxidized agent, which are responsible to reduce the quality of the work, to reduce the quality of the soldering, and to reduce the iron tip. For maintaining this, the quality, we require a sufficient amount of temperature, and sufficient amount of temperature is not obtained. That is means some oxides are formation on the surface of iron tip. For the removal of this, for preventing the iron tip of the solder, we require the flux for the coating. It will prevent the from oxide formation. The application of soldering are as follows. That is, the soldering is used in the electronics and in the jewelry metalwork. Some refrigeration components are also assembled and repaired by the higher temperature silver soldering processes. So you can see in this diagram, these all are the application of the soldering. With the help of soldering, you will just weld all the component, and just you can see these are very fine finishing, and it will be look like a very good and attractive. But the good surface quality maintaining the feature of soldering without any damage of the workpiece. So these are the applications of soldering generally used in the electronics, mainly electronics generally used, and sometimes it will be used also in the jewelry for maintaining the jewelry, for we can say that maintain the good quality of workpiece. Some little tiny parts will be joined with the help of the joinery also. This will be helpful to you. This will help you to understand how to maintain the good quality with a little deformation of the workpiece if you want to join. It is a smaller area. It is not possible with the electric arc welding or any other type of welding except the solder. So this diagram, this board indicates very clean and very fine finishing, and without any defect or without any damaging of the board. It is happening only on the soldering process. So these are some parts of the section and soldering. If you want to join some electronic items or any jewelry items or some refrigeration component, if you want to repair or maintain, so you will be prefer the joining. It will helpful to you to maintain the good quality of the workpiece for the help of soldering. It can also be used as a semi-permanent patch for a leak and a container or cooking vessel also maintaining by a semi-permanent patch for a leak. If some portion leak from or a container or a cooking vessel, then you also join with the ram. So you can see this diagram. This is a soldering. This is a iron tip. You can supply the 400 degree temperature at the iron tip, and the solder passing with the removing with the heating of the solder and the melt, and just join the point. This is a soldering. So it is also a metal joining process. It's very popular for the welding as a part of electronic and the jewelry items. It is very popular. So electronic soldering connects electrical wiring and electronics component, electronic wiring and the electronics component. So electronic soldering connects electrical wiring and electrical component to be printed. Circuit board, PCB. And this electric board are used for the machining purpose also. So with respectively, I'm just telling you, it will help to understand the metal joining processes to maintain the quality, and the applications are as follows. Advantages: it is a low power is required, low process temperature required, a microstructure is not affected by the heat, easily automated processes, dissimilar material may be joined, high variety of material may be joined, and thin wall part may be joined. So these are some advantages of soldering to keep in mind. There are also disadvantages also. That is, first, the larger section cannot be joined. It's just used for the small sections. Fluxes may contain toxic components, or it will be required for the preventing from the pre-oxidized agents. Third is the soldering joint cannot be used in high temperature application. Soldering joint cannot be used in high temperature application. Fourth is a low strength joint, because there is not too much amount high strength we are required for the welding, this type of welding. Fifth is careful removal of the flux residual is required in order to prevent corrosion. So these are some disadvantages of soldering RS codes. Now the second term, it is brazing. What is brazing? It is also a type of metal joining process with some advanced feature. Brazing is when a filler metal or alloy is heated to its melting temperature above 450 degrees Celsius. So you can see in this diagram, that is a metal or alloy is heated by the filler. You can see here when a filler metal or alloy is heated, and after heating you can melt the filler metal and just fill up all the area where you want to weld this area, the cut section here, you want to weld. So you just keep the filler metal on the surface of this weld, and you just passing the high air at with the 400 to 50 degrees Celsius approximately, and the filler metals melt, and all the areas filled with the empty area, and the welding is done. So in this type of in this case, only filler metal melts. There is no melting of workpiece metal. There is no workpiece melting in this type of brazing section. Only filler metal is welded. So these are the some assumptions we can say. These are the some we can say that there are some good feature of the brazing. It is very helpful to understand. It is helpful to understand to obtain the good quality of surface also, because there is no melting of the workpiece metal. So it will help you to understand. Second is the brazing process are as follows. First is, in a brazing operation, you apply heat broadly to the base metal. In a brazing operation, you apply heat broadly to the base metal. You can see the diagram first section here. First section, it is broad heat to base metal. First of all, this is a base metal you want to join. So you first of all heated the base metal, because when you contact with the filler metal, it easily to be contact and easily melted by the heating of the workpiece surface. So the filler metal is drawn through the joint to create the bond is capillary action. So this is a simple, keep in mind. You can put this, you can see these are the two metal we joined, and these are the between the gap, and you can put the solder in between the gap, and you can apply the high temperature of arc to the filler metal, and after melting the filler metal, this empty gap are filled by the welding, and after solidify, you just shown that these are the joined together, and this is making the single piece rather than the two piece. So these are the advantages of we can say how the brazing process will be done with the help of the, we can say heating the first of all base material, and after the heating of the, we can say the filler material, and all the heating we can melt the filler material and fill up the empty area. So these are the process of a brazing operation. You just find out. Brazing rod, that is the torch brazing flux is applied to the part surface and a torch is forced used to focus flame against the work at the joint, and reducing flame is used to prevent the oxidation. So this is the diagram which is shown in the for brazing operation. You can see here. First of all, you heat up that surface here where you want to join. This is a square section. If you join with the cylindrical area in the midsection by the help of the brazing. So first of all, you add the filler material here, or heating the filler material on the surface you want to join, and after melting this filler material, the gap will be filled by the this solid material, and completely we can say that the welding is done. So it's just simple because a reducing flame is used for the prevent the oxidation, for the prevention of unwanted moisture contents, or for reduce the quality of the weld. So prevent it will easy to understand. Furnace brazing, this is also another different type of brazing, that is at some sections are also discussed. That is the first is the furnace welding, used to heat the workpieces to be joined. Furnace brazing used to heat the workpiece to be joined by brazing operation. The component part and brazing melt are loaded into the furnace, heated to the brazing temperature, and then cooled and removed. What we do basically, the use of the heat, first of all, your work is to heat the work surface. What surface area you want to join, first of all, heat them down, and after the brazing operation will be performed. It will easily to maintain the temperature, or we can easily melt the material with what you want to join the empty area. It will help you. It's a diagram to connect it with them. Brazing joints. Also introducing the brazing, that is a process that use electrical resistance of workpiece and high frequency current induced in the same as a source of heat generation. A process that use electrical resistance of workpiece and high frequency current induced in the same as a source of heat generation. The part are preloaded with the filler metal, and the place in the frequency, we can say AC current will be required for metal joining. So these are some diagrams, these are some processes we obtain. We require some power to require the high temperature, to increase the high temperature on the operating point. And this machine, the transformer will transfer will get the energy from the power source and then transform the energy to the workpiece, and be able to conduct the heat from the health of the from the melting this filler metal and put on the surface operating device, and you can fix the workpiece here to join permanently in the place of the high frequency in the AC field we obtain. Deep brazing also the example of the one other type of brazing, that in which assembled part are typically dipped in a heat chemical bath, which serve as both fluxing agent and heat sources to melt the pre-applied filler material. So I can see in this diagram, this is a chemical bath, and this is we can say a bath sheet as a filler by the molten flux electrode are here. And you want to join the brazing joint, before joint and after joint, you can see in this diagram, these are the completely type of brazing point are here to be joined after that is. So what happened is two sections here, this section, another first section here, there's a light and left, and there are two sections, and after, so before the brazing operation, after the deep brazing, you can find that these are completely joined to the single hand. A single operation. These are the applications of the brazing, and you can see in this diagram, these are some applications. If you want to join the pipe like this, multiple pipes are joining on the single pipe, and you can join with this. You can also done by the brazing. It's very fine smoothing quality, and you will provide the very good surface finishing also after the welding. So these are the some advantages. You can join the pipe also with the cylindrical pipe point with a disc, and you can join like this. These are the some example. You can say these are the example of soldering. If you want to join the some tool for the key operation, this is a key, and you join with the these are the some with the help of the brazing. So these are the some very applications of the brazing. After brazing, the finishing will be done by the machining process. It will attractive to after the machining process, the workpiece will be attractive after machining if you are done with a good finishing and grinding you are using for the abrasive part material. Abrasive grinder we use for the cleaning the unwanted surface or unwanted material we attach and we remove the unwanted material. After that you will be find the final product you can like this. It is a very good and shining product are obtained. So these are some basic applications of brazing which we generally use in the now applications, our daily life. All are done by the brazing. The advantages of brazing are any metal can be joined, including dissimilar metal. It is the advantages. Any metal can be joined, including dissimilar metal. Dissimilar metal is not joined by the brazing. Only similar metals are joined. Any metal. Second is certain brazing method can be performed quickly. So this brazing method certain maybe can quickly be obtained. It quickly be procedure be obtained for the metal joining. Third is the brazing can be applied to join the thin walled part that cannot be welded. Fourth is in general, less heat and power are required than in the fusion welding. So it is some advantages of the brazing. If you are doing the brazing, these are some following advantages you just keep in mind. It will help you to operation perform with a very low investment of cost. It will help you during the brazing operation. Also, there are some disadvantages because every part have an advantage, disadvantage. So the disadvantages are as follows. And the first point is joint strength is generally less than that of the welding joint. Second, also the strength of the good Brazil joint is greater than that of the filler metal. It is likely to be less than the of the base metal. That is, high service temperatures may weaken as a brass joint. And fourth is the color of the metal is brass joint may not match the color of the base metal part. It is other some disadvantages. Now there is a comparison between the soldering and the brazing, welding, soldering, and brazing. Or difference between the both the three parts. There is welding. In welding, there are the stronger joint used to bear the load. Strength of a weld joint may be more than the strength of the base metal. As compared to the solder, these are weakest joint out of the three and not meant to bear the load used to make the electric contact generally. And the brazing is there are the stronger than the soldering but weaker than the welding. This can be used to bear the load up to some extent. Temperature of the welding obtained at 38,000 degrees Celsius, 3,800 degrees Celsius, and then the temperature of soldering the 4,050 up to, and in case of brazing that is 600 degree obtained in the brazing. And third point, that is the workpiece to be joined need to be heated till their melting point. And in the soldering, there is no need to heat the workpiece, and the brazing the workpiece are heated, but there is a low melting in the low melting point. Mechanical properties of the welding may be based on change of the joint due to heating and cooling, and the mechanical no property there is no changing after joining in the soldering, and some maybe changes in the mechanical property after joining is negligible, but it may be changes sometime in welding brazing process. Heat cost is involved at the high skill required for the welding. Cost involved in the labor required for the, we can say that in the soldering section. And cost involved in skill level required for between the others two as compared to the brazing. Next is the heat treatment is generally required to eliminate undesirable effect of welding in the welding section. And soldering there is no heat treatment is required. And in the brazing there no heat treatment is required for the after brazing. And in the case of the seventh case of the welding, there is no heat treating of the workpiece required before welding, as it carried out high temperature. And in the preheat of workpiece required, the soldering is good for the making good quality of joint and the soldering section. And in the case of the brazing, the preheat is desirable to make the strong joint, as the brazing is called as relative to the low temperature. These are the comparison between the welding, brazing, and soldering. As a conclusion, we can say that soldering and brazing are the two allied processes of the welding. The major difference between the there is a huge amount of heat is required in case of welding, and the low amount of heat is needed in case of brazing, and very low amount of heat is consumed in case of soldering. So welding gives the high strength of joint when which are applicable to here the low heavy load, and joints made by the brazing and relatively weak and soldering joint are very weak to the bear of the load. And generally the soldering is used to make the electrical contact difference method of the brazing are described in this cuts in this unit. There are no different weld varieties of the soldering method are the some applications we have mentioned in the slide today for understanding the better knowledge of soldering and brazing. Now at the end of the this lecture, end of the unit of the two, this is the last lecture of the unit 2. At the end of this lecture, I am just asking some multiple choice questions. First is that the liquid temperature of the filler material used in brazing is as follows: 150 degrees Celsius, 427 degrees Celsius, 723 degrees Celsius, and 1000 degrees Celsius. The correct answer is that is a B, that is 427 degrees Celsius obtained in the brazing. Second, the copper and the aluminium can be joined by brazing when dash alloy is used. The B is aluminum silicon alloy is used in the condition when copper aluminum is used for brazing. Third is which of the big following filler used metal is used to electric industry. Options are bag 1, bag 3, bag 5, bag 6. The correct answer is bag 5 is used for them. Fourth is nickel filler metal are heat resistance up to dash in short time services. Options are 610 degrees Celsius, 982 degrees Celsius, 102.04 degrees Celsius, and 166 degrees Celsius. The correct answer that is C, that's 1204 degrees Celsius are obtained. Fifth is which of the following filler metal used for the carbide tip brazil? Bag 1, bag 4, bag 8, and bag 18. The correct answer for this B, that is bag 4 is used for the brazing chip. Sixth is a tin zinc solder are used for joining. That is the option are aluminium, zinc, copper, glass. The options are as follows, and the answer is A. Aluminium tin solder are used for the joining aluminium. Seventh, what is the solid as the temperature of the tin leader solidify? 182, 1297, 444, 604. The correct answer that is the 183 is the used for number. Eighth is the addition of dash increasing the mechanical property of tin leader solder. The answer is options are bismuth, tellurium, antimony, and molybdenum. The correct answer is C, that's the antimony. Ninth, that is the filler metal used is brazing has melting point of above. The options are 200 degrees Celsius, 300 degrees Celsius, 420 degrees Celsius, and 520 degrees Celsius. The correct answer of the question is C, that is 420 degrees Celsius answer. And the last question, that is in soldering, the melting point of filler metal is below 420 degrees Celsius, above 20 degrees Celsius, below 520 degrees Celsius, and above 520 degrees Celsius. The correct answer that is above 420 degrees Celsius. And in the last, I'm recommend to some books for understanding the metal joining process. Unit 2. Recommend these books. These are the some author. I hope you understand this today video. And if you have any query, any doubt, you will be ask me on my my email ID. Drop my email amit.tiwari@mygainwriter.com, and you will be contact me on my mobile number also. That is 869039. Thank you so much for listening patiently. Thank you so much.